back to the lecture 2. Uh, so, and I believe you've done your assignment. Okay, that's cool. Okay, if you have any question as regard the assignment, please don't hesitate to ask and drop it at the comment section. Okay.
Before we dive into today's agenda, I would like to reiterate, or should I walk you through what we've done in the time file for the purpose of those uh, who haven't gone through what we have done, and so that to put them on the same pedestal as we have. So, looking at the introduction to pandas, we've looked at, or if you have not watched the video, I would advise you to stop this video and go and watch the first two video we've published. Okay. We look at and pandas. Panda is a tool, an open source Python library. We use it to read, write, manipulate, and analyze data sets. Why pandas? Why do we choose to use pandas? Actually, easy exploration and manipulation of large data in an efficient manner. We can use it to analyze large volume of data with ease. The large volume we're talking about could be in millions or billions instances depending on what we have. Okay, what makes pandas a popular tool? You can see that easy to read and learn, extremely fast and powerful, integrate with other visualization libraries. We have data structure. We have two fundamental data structure objects of the core of pandas library: series and data frame. And we consider series to be the column that pandas data frame comprises of nth terms of series, meaning we can have one series. One series could equally be called a data frame. Why data frame can have two, one, two, three, and so on and so forth of series, but series only has one column. That's an instance. Okay, so we've looked at that. Please, if you have not seen the video, stop this and go and watch the first two video that has been published. So coming down to this place, let me run this just to continue with this. Okay, and then we look at creating data frame using list, and I gave you assignments to create your own data frame using dictionary. So we looked into the data loaded. We are using Titanic data set, and of course, if you want to read about that tragedy, tragedy that happened in 1912, about that shipwreck. So go and read about it and read about how people were rescued, what are the parameters or the features that guarantee survival of an individual. There are some people that were offered lifeboats, and why some people drown with the ship. So the ship was actually going from Southampton to a place in USA. I can't remember now. So on their way, the ship collided with iceberg, so he capsized and people died. They lost their life. Like 60 to 70% of the passenger lost their life, both young, old, male, female, and all. So you can read about that. So, and of course, the data set is made available through AI Planet. I use the link shared on their website. So that's where I got the data set from, the link to data set. So for the purpose of education, tutorial and learning, you can equally use the same. So I've included the link already on this our notebook, so you can download it and check it out. So from here now, let me see, we have, okay, that's the link. So first thing, what we're going to be looking at now is the indexing in Pandas. Indexing in Pandas. If you look at the left hand side of the screen, we have the outline there. So you just follow the outline. I have it itemized already. So in indexing in Pandas, we have two different method for indexing in Pandas. We have the iLook and lock. We have iLock and lock. So what's the difference between the two? If you look at the left hand side the notes, we say conceptually iLock and lock are similar. However, the difference between them is that iLock considers the default indexing, while lock ignores the default indexing. Okay, so we're going to look at it from here. So let's see the data frame again, and this is our data set. That's the first 5 rows. We can equally check the last 5 rows as well by using the dot method with tail method. Dots with tail method. Okay, so if we click that, can you see it gives us the last 5 row of this data set. That's that. So but what we are interested now is to index using the we are, we are interested in looking at that indexing in Pandas. So iLock takes two parameter. It takes two parameter, call it I and J. Let's say I and J, they are variables. Actually variable could be any number actually. So the variable means that you can assign a values to this. So if this variable, the I there stands for the x coordinate, the x coordinate of this table. And what is the x coordinate? Is the row of the table, while the j there stands for the column. That's y coordinates, it stands for the column. So now if I specify, let's assume if I want to select all the column, all the data sets, all the data sets using this iLock, I will just put column the column in place of the I and in place of the j. So meaning that read all the rows and read all the columns. If I run this, please pay attention to what we have initially. We only have the last 5 instances. So by the time I run this, it will give us the all the rows. Can you see all the rows we have in our data set, which is 891, and also all the column. Now that is it. Now let's now assume we want to use this same method, this iLock, to print the first 5 rows in this our data set. So how do we achieve that? Don't forget, I said the first parameter you pass is for the what? For the row, while the second one is for the column. So we want to print the first 5 rows. How do we go about doing that? We can specify in using array. How do I mean? What this is what how that actually means. So you create a Python list and put the index. Don't forget the index start from 1 0 1 2 3 and 4. So that's 5 rows. By the time I run this now, pay attention. What do you see? Is equivalent to what dot head we give to us. So knowing pandas, it gives you power or ability to manipulate your data in an effective way as a data scientist. So now looking at that, we instead of enumerating all those indexes. What if we have 1000 indexes? Will you be doing that? That would be time consuming actually. So in order to do that, there's a way we can optimize this. Just remove this. So instead of printing all, what you do, you can specify from where to where you are starting for. That is onset, that's where you are starting, that start point, which is 0. Then the column, where are we stopping? 5. However, now if you look at this, I say from 0 to 5. In this range, now this is the range we are specifying. We want to print the first 5 row. Okay, now the 0 there is inclusive, the 5 is exclusive, so it stops from 4. And know that if you start the counting, humanly counting, you start 1 2 3 4 5. Okay, so if you replace that 0 to 1, it still equals to 5. Okay, so that's our computer, and based on the method we are using, the iLog use, or should I say considers, the default indexing. So now let's print that and see what we're going to have. Can you see nothing changes? So it means that what the head will give us, what itemizing all the indexes will give us, this slicing 0 column 5 equally gives us. Okay, now going forward, what if we don't want to print all the column? As you can see, we have all the columns being listed. We have 12 columns. We have the passenger ID, survived, passenger class, name, says age, sibling, spouse, parent, children. We have tickets, we have fare, and we have cabin and embarked. And of course, our target variable in this, I told you this is to just learn about it too. The next lecture we're going to be having, that we have to do with EDA, exploratory data analysis. So that will help us to see into the meaning of the data. But now we are learning about it too. But however, in linear algebra, we have simple linear algebra. That's when you have one independent variable, that's the standard linear algebra. But we still have multiple linear regression, whereby we have multiple features that determines the outcome of the dependent variable. That's why. So now, but we're going to go about, don't bother yourself about the term I'm using. Okay, so just focus on the two we are using, how you can use it effectively as data analyst or data scientist. So now, looking at that, let's just print out 3 column out of this 12 column. How do we achieve that? The same thing, that the same method applicable. You can use listing, or you use what we have used, which is effective and optimized. You can say is 0 to 3. 0 to 3 means 0 1 2. That's 3 column. So always put in your mind, the first value you supply is inclusive, the last value is exclusive. So you have to do your mathematics and know what we are talking about. So meaning that, okay, let me comment beside it. Let me say is 0 column 3 means that we are supplying from 0 1 and 2. That's what it means. And if you look at how many items do we have in that list, 3 items, so which is equivalent to our intention. So now running that code, now we have 3 columns, which are the passenger ID, survived, and the passenger class. Okay, and we have 5 rows as well. So let me spread this so as not being to I'm going to make the code available. Of course, the first code we used is on my GitHub, and I shared the link under those videos. So if you check it, you can access it. It's made public. And looking at this now, okay, sorry, let me stop a little while and see the record, then continue. I believe you enjoyed the short break we just had. And continue from where we stopped. We'll look at how we can slice the data frame using iLock. Without further ado, let's look into another way of selecting the intercept between the column and the row. And of course, the intersection between the row and column is called cell. So if you look at it now, let's look at that survived column against the instance index number 3. We have one to be the intersection between them. So assuming that we want to actually pick out that intersection, the value in there, so how do we navigate our way through into that? Note that the counting of the column also starts from 0 irrespective of the name given it. So if you look at the passenger ID, that is count 0, 1 and 2. Okay. Okay, let's see the whole data frame. We know we can use ILO to select all the data frame as we have .l as well. So let's run all. Now this is the our data set. We have the instance of 891 rows. They were passenger or instances we have here, and we have 12 columns. So starting from the passenger ID, survive, passenger class, name, sales, age, sibling, spouse, and parent, children, ticket, fare, cabin, and embarked. So if you look at that now, so assuming that we want to pick out the intersection between the name, we want to select the name of a particular passenger of ID. Let's say we want to select the passenger. Let's assume we want to select the row or record number 50. Record number 50. Let's see that how. Let's say that. We call the name Titanic. Titanic underscore df dot ilock. Yeah, index number 50. That's comma. Then the whole column we are getting that. Let's run that now. Cool. As you can see, we have all of this. Let's see what we have. Maybe put the 50. What this one is doing is that we are selecting from the 50 index 50 down to the last rows, but that's not our intention. Okay, so what we want to do is to just select the one record out of all of those. So let's see. So this is the record that is peculiar to that particular passenger at um row number 50. Let's assume let's take in row 51. Let's say 51. Can you see? So that 51 is, remember I told you of the starting index and the ending index. The starting index is inclusive, while the last index you supply is exclusive. So it end at n minus 1. So if this is n, if this one is n and this is n plus 1, so subtract 1 away from n, so it returns the lesser value. Okay, so that we have 50 to 51, so it gives us only one passenger. And of course, if we only supply that 50 without giving the without supplying the range, it actually gives us in a series form. Okay, and that's peculiar to that particular passenger at index 50. Don't forget the counting start from is 0. Okay. uh-huh. So let's do what we just did initially. 51, we know that that is what exclusive. Now we want to get the intersection between the column and the row, saying that, well, let's assume this particular passenger now, passenger ID number 51. We want to know the name of the passenger, or want to fetch out the name of that passenger, which is the inside intersection, right? So how do we achieve that? So it's very, very simple. Okay, so what do we do? You know that the first argument we supply here is peculiar towards to the x-axis, that is the record, okay? Why this second argument stands for the column. Supplying that column means we are selecting all these columns starting from the passenger ID down to the embarked. So now we are interested in the name of the passenger that we just, you know, um, printed out now. So how do we get the name of the passenger? The ILO does not take string. So some person might be thinking maybe we can use the name of the column, say name. Is that so? Let's try that out. Can you see? It gives us what error. So what kind of error do we have? If you look at that, that's value error, saying that location based indexing can only have what integer slicing, start point is included, end point is excluded, which I've explained initially. List like of integer, boolean array, these are the type that is expected in as what as the argument of ilog. So we don't use string, so we use what integer. So if you look at that name, I told you the index count starts from 0, 1 to 3. So let's look at the count. The passenger ID is 0, survive 1, passenger class 2, 3. So the name fall at number index 3, okay? Index 3. So what do we do? Just give it type 3. That's index number 3. So let's run that and see what we're gonna get. Correct. You can see now. So this helps us to select the intersection between that column and the row, and that intersection is the name of the passenger. Okay, so that's how it goes. And of course, we equally detect that ilog does not take in string as argument. Okay, it uses integer list or boolean value. Okay, so let's go further and look at the it. We can equally select entries using negative value. Okay, let's look at how that plays out. In order to add a new shell, you click on this plus. Can you see where the cursor is? So that gives us that. Okay, if you need to do that, and to remove it, just click on the scissors icon. Okay, let's select the last five instances of this data we are working with. Titanic df.ilog. So don't forget, when you supply two column without value, without indexes, it equals to you printing the data frame itself. So what do I mean? So this is what where is it? Okay, yeah. All right, this is what. Let me create a new column here. Good. So if you just simply type the name of the data frame and you print it, it gives you all the instances you have in the data frame, okay? But however, if you look at what this also gives us, they give the same result, isn't it? So it gives all the rows, and this one equally gives all the rows. But however, our interest is to select the last five instances as we have it here. Can you see? This is the head. Okay, this is the first five rows. So to get the last five rows, you use tail.
It's a method. Then run that. Can you see? It gives you 5 last instances. So we can equally use the iLog to generate the same. I told you, don't forget the first column, it's deals with the rows, and why this deals with the column. Okay, you might want to select out of this 12 column. If you don't want all the column, you can supply the value here, the starting value and the ending value where you want it to stop. And similarly to the row as well, you can supply the starting and the ending. Now we want to generate the same value that this tail gives us. So how do we get that using iLog? We use, if you look at it, the counting start from 0 down to 5890. 890. Can you see it now? So how do we generate the value? So we do reverse counting. So instead of we counting from ascending order 0, 1, 2, 3, we can start descending order. Okay, that instead of 89, we start the negative counting. That's -1, -2. Now let's supply -1 here and see what we're going to get. So if you supply -1, you start with where you are starting from. So if you are starting from 0 to 5, when you are using positive index, okay, you start from the 0. So now the least value when you are counting negatively is -1. Okay, cutting from, we start -5 to -1. Let's see what gives us. So if you can see now, we have -5, -1. So -1 is excluded. That's why we don't have 890. Can you see it now? So what do? We remove this last value we supply, since it is exclusive. So in as much you have not supply, you are not supplying uh, the the upper bound of the range, is going to print all starting from the initial value -5 down to the last index. Okay, let's run that. Can you see it now? So it gives us what the tail will give to us. That also this gives us as well. However, if you look at it now, we can equally select the column like we have done initially, previously. You can equally select the number of columns that you want to display. Let's assume I want index 0. Don't forget, we can't use string. I think we have seen that in the previous lecture. So now let's assume we want to select the last 5 columns. So what do? The same thing applicable, just apply -5. So it select us all the last column. Can you see it now? I think you didn't see that. Let me show you. Let me replay. Let me do that again. Can you see it now? So the last 5 column is this, and this, right? That's parent, children, ticket, fare, cabin, and embarked. So supplying -5 trims off the preceding columns. Okay, see that? Can you see? And if you want to select, let's look at that. You want to select the passenger ID, and let's say name, and let's do that together. Let's supply that. We have a way of arranging it as well. We can equally supply it this way. Let's say we are looking at getting number 1. Let's see. Can you see? Passenger. So, comma, the passenger ID is 0, index, the survived is 1. However, let's say passenger ID, the name, let's follow by the name 0, 1, 2, 3. 3 is the name. Let's look at that. Can you see that again? Now let's equally say we want the age. Okay, it's 4. Good. And also we want it to follow by age to be 5. Good. And followed by 5, 6, 7. Let's look into their ticket. That's 5, 6, 7. Let's count again. 0, 1, 2, 3, 4, 5, 6, 7. 7, 8. Now 8, let's supply 8. Good, ticket. Then fare, we can jump that. Let's jump that. Let's now print survive. Let's equally print survive. Survive is 0, 1, 1, index 1. So let's look at that. Can you see? It helps us to create this table. So like this table now, we can write it to file. If you are to extract few feature out of this feature you have here, most especially when you are doing feature engineering and all, you feature selection, you might needs to create another data set from the data set supplies you can create another table from that. Let's write this to file. However, let me write this to file. So we have the same row now, the same column, the same row but 8 column. We can write it to file. How? Don't forget the way we wrote the other one. I think I explained that initially. We write it. Let's save this inside a table. Let's call it extract Titanic Titanic extra data set extra. Let's say extra. Then we've saved that already. So let's print it out so we can see what we're talking about. Titanic extra. Can you see it now? We have 891 rows and 6 columns. So let's write that to file. Let's call it Titanic, the name of the variable Titanic extra dot to CSV. Then the name of the files that is going to show, the name of the file is going to show Titanic extra dot CSV. So that's the extension of that file. The index is equals to false. We don't want it to show it false. Okay, now let me show you something before then. Let's click on this. You can see this is the folder. We don't have that. We have Titanic data CSV and all. So now let's go back and run the code. This is the line of code. Let's run that and see. Yeah, it has run. So let's go back to the folder. Then we have Titanic extra. Let's click on that. Can you see? We have the passenger ID, we have the name, we have the sales, we have the age, we have the ticket, and we have the survive. So in feature engineering or feature extraction, you might want to do something of that nature. Just select out of the column supply you or the raw data given you might detect that most of them are not actually necessary. So you want to select the most important feature in that data frame. You can use I love to select to slice that out, and you can see we use that here. Okay, so now my assignment for you is to check how to use. So assignment, let me do that. Let me give you assignment. So we have looked into hilog to hilog, comma. Now try the order indexing technique that is log of log place of log.
Good. All right. So do that assignment while we go to summary. So what is summary? Oh, you want me to show you the data set we just created? Okay. All right. Hold on. Let me show you. Um, let's create a new. Okay. So the name of the file is what? Titanic Estral. So let's read that. Let's read the file. Let's call it um, um, Titanic Estral data frame is equals to pd.read p read csv, then the name of the file Titanic Estral csv. So let's read that. So we've read it. Let's print it out. Titanic Estral df. Can you see it now? So that is how to create data frame or create files or CSV file out of other files, okay? Out of the initial data frame we read, the Titanic data frame we read, now we have sliced or selected some features out of the 12 features. So now we have, how many columns do we have now? 6 columns. The name, the sex, the age, tickets, and survived, and probably passenger ID. So you've seen that. All right. Without further ado, let's go into summary.
Going forward, we have summary. What is summary? Summary is the brief information about the whole data set, okay? And there are two methods they're going to be using to check this brief information about the data set we are using. So the first one is the info method, and the description with a describe method. And of course, I'll love to show you something. You don't need to cram all of this in your head, okay? You don't need to cram it. You can look up to the Pandas documentation, and of you can equally use help method to see how you can use a particular class and its attribute and method, okay? Data frame is actually a Python class that has attributes and methods, okay? So for us to know what embeds in this class data frame, you can use help. What's the name of the one we are using? Okay, Titanic underscore df dot let's say info. Let's see how can use that hub, or you can just supply that the data set we've been using, okay? Let's run that. Good. So you can see this data frame, it's an object, okay? It's an object, so it's a class. Can you see it here? So this is the definition of it, and you'll be able to see all the attributes that is associated with it, and okay, it's called a parameter, and method that are also associated with it, or the function that is also associated with it, okay? This is a construction, how to create in it, which we have done. You can check the type of the column. So this shows the column. This attribute shows the each column data type. Okay, and if you go further, it means we can set the type. We can set this to integer bit 8. Okay, so that's that. Let's scroll down. Let's see other method we can use. We have seen how we can use array to create data frame. We have done that also. So scroll down, you see a lot of method. So you use the one that actually, so you can see now you don't need of cramming it. Just come down here, check what you want to do. And even if you don't know what you want to do, check it and read all that is there. You will, by going through it, it will shed light on what you really need and what to do. Okay, now let's see info. So let's search for the info. Let me search on my PC. I press command F, or on the PC, rather on the PC, Control F. On the Mac, command F. So let's search for info method. Good. Yeah, so this is the info method. What it does is the method prints information about the data frame, including the index, the type, that's data type, the columns, and the non value, and the memory usage. So you can see that now. So now let's look at what offers us. So you can see the four things that it print out for us. So it's a brief information about the data itself. So let's do that. Let's come here and do that. Okay, Titanic df.info. It's a method, so you have to end it with parentheses. So let's run that. Good. So don't forget, it gives us what? The index type, the index data type of each column. Then if you come here, it first of all gives us that is equally what? A data frame. Even the result given to us here, it's a data frame. Okay, it's a data frame, it's a table. So the range index, of course, the entries are 891 passengers. Okay, and it ranges from 0 to 890. Then the third, that is the first thing that it gives us, right? Index types. So it gives us this also. Data column, there are 12 columns. As you can see enumerated here, from passenger ID to embarked. Okay, then here we have the first column is the serial number of the column. So starting from a 0, the counting starting from 0 and ends in level. Name, the first column name is this, survived, and dance to embarked. Then the as we have here, the non-null values are here, the value that they are not missing. So we each column, that is passenger ID, is complete. We have all the 891 passenger ID intact, so nothing is missing there. So the survive, nothing is missing here, nothing is missing. But when you come to the age, we can see that the number dropped. So it shows that there are cells, there are values that are missing in this column H. Continue. and also the cabin too has missing value, and the embarked as well has missing value. So we're going to look at how to do that doing the EDA. Okay, all right, so we are learning the tool now. Okay, let me close this. Okay, now the data type, the D type. So it also shows the D type. So the passenger ID data type is what? Integer, okay, of 64-bit. Then the survived also is an integer, 1 2 3 4 without floating point. Then the passenger class also an integer. Now the name, an object. Name is a chunks of symbols. So like, name of the passenger could be Peter Sunday, you get. So that string is an object, okay, is an object, Python object. Okay, now age also, no, so okay, this one is female and male, also is an object. Then this age is float. Why float? Decimal value. So we're going to check that out as we progresses. Now siblings and spouse is also counting number 1 2 3. Parents and children, pouch. So we have integer as well. Ticket is an object. Fare is what? Floats, yeah, 20.5 cents and all. We have cabin also an object. We have this also an object. Then compile all these columns together and give us the summary. The summary of this table we still have here. It gives us the summary of this table we have here, the column, the data set. Then it counts all the integer and gives us the result here that there are 5 in number. As you can see, 1 2 3 4 5. Okay, and the float also 1 3 of 2 float and object 5. Then the memory usage for this data set is 83.7 plus kilobytes. Okay, good. Now we have seen the info method. So let's look at the next method, which is this, and you can see this is the syntax that I've used. Okay, the data frame name dot the method. So let's look at the describe. Okay, Titanic underscore df dot describe. Run that. Good. Okay, before we run it, let's equally look at the help. Let's look at the help. Let's look at the help and search for describe as we did for the info as well. Let's find. So describe. Good. As you can see, so let's see the definition if we have it here. Okay, what describe does, let's look at. Let's look at it. I want the definition. I want to show you the definition of that describe. Okay, let me do it this way so that we can get it. Okay, yeah, it's here. The definition is should be somewhere. Yes, describe. Yeah, this is the definition. Can you see it here? So describe method takes self percentile none, include none, this exclude none. Then it returns self, it returns data frame as well. So it generates descriptive statistics. So the the brief information about the data frame that this returns is what? A descriptive statistic about that data set. So descriptive statistics include those that summarize the central tendency. We have dispersion and shape of a data set's description. Okay, we have excluding, which is none, and value, none. So let's look at the parameter that this equally returns to us, like we have in the info, the year. So these are the note, what it returns us. It returns, we have what? It returns a table that comprises of all of these statistical uh, central tendency, parameter. Okay, statistical parameters. Here we have what? We have, for numeric data, the result index will include, for numeric data, meaning that we have numeric data, we have object data, okay, or the combination of the two. So for the numeric data, when we are using described on that numeric data, it will give us this. It will give us the count of that, each of the column and all. We're going to see it. The each of the column is going to give us the mean of each of those column, the standard deviation of each of those column, and the minimum value, the maximum value of each of those column, as well as the lower 50, upper percentiles, and all 50, 25, 75. And of course, percentile is the same as medium. Okay, it's giving us the similarity of that. So for object data, that is the strings or timestamps. Okay, for that, those are the object. I told you string are objects, Python object. Now the result index will include the count. Also, this one to return the count. It only counts the instances in that each of the column. Then unique means the unique, it to return the count of the unique value. Okay, we're going to see that top and the frequency, the most occurring value. Okay, occurring value. Then we have top is the most common value. So top also is the most common value as probably frequency as well. The frequency is the most common value. You can see now top and the frequency are similar in this regard. Now timestamp also include the first and the last item. So let's look at that in action. Okay, so let's look at that. So let's use the describe here. Let's use that method here. So we have Titanic underscore df dot describe. Let's run that. Good. This is for numerical data. For numeric data. Abi, let's look at out numeric data. Okay, for numeric data here. So you can see we have the count, we have the mean, standard deviation, we have minimum value, we have 25 percentile, 50 percentile, as 50 percentile, that is equivalent to median. Okay, that's equivalent 75% and maximum value. And of course you can see each of the column that are integer base value, don't forget numerical data is integer base value column. So on any other column that does not have that, their objects, they will be excluded in this result. We have 12 column, but here we have what? How many of them? They have 1, 2, 3, 4, 5, 6, 7 of them. and as you can see, 7 of them numerical value, that's float plot. What we have from the info now giving us that their numerical value equal float or integer. So combine the two, that's 7 column. So, and of course we have that 7 column here. Can you see this, they can be computed mathematically. Okay, so we have that as well. So let's look at it. For the passenger ID, the count is 891. What does that mean? That is the entries that, as we have in the info we have here, the entries, the non value. Okay, so the entry is there, 891, and the survive as well there, but the age missing as we have it in when we use the info. Don't forget, this is what brief information of the data set given. So these are completed, but the age only is missing. It's missing some passenger ages. Okay, then this mean simply means the average when summing all of the passenger ID divided by the total number of this. In statistics, to get the mean we use summation f of x, summation f of x divided by summation f. Okay, so summation f is the number of sample or population, the capital letter N. Okay, which is one in our state now, it's equals to 891. Okay, 891. So 891 divided by the number, the addition of all the passenger ID, 1 plus 2 plus 3 to 180 something. So everything adds together divided by this returns this mean. Okay, it's calculated in that order. So survive as well, survive also is on that for us. Okay, and survive is it has value of 0 and 1. We're going to look into that data set very well. So adding us together divided by 891, it gives us this as the mean, that is the average. It can't exceed it. Even if it exceeds it, it can't go outside that. That's the central tendency. So it can equally be plus some value or minus some value. So it will be around this mean, around this average, so and so on and so forth. For the standard deviations too, we have the standard deviation, the how you can see differ. So we have the standard deviation, we have the mean. So the least of this number is what, 1, and the maximum is what, 891. If you are looking for the range now, you just say maximum minus minimum, that is range. In statistics we have what, we have maximum minus minimum. So this returns the range of each column to us. Okay, to see what's the difference between those mean and the maximum. So that is that for the summary. I believe you okay. This is for the numeric. Let's look for the object. So in case I want to get information about the object, the 5 object, how am I going to get that? Very simple. What you need to do is to just pass an argument in this place called include. How do I know? Look at that. If you look at when we are looking at this, we were given on how to use describe. Can you see describe? But for the object, let's see, for the object, what do they include in that parameter? For the object, this for the all, can you see all column of the data regarding of the data set, whether data type, whether object or wherever, object or numeric. But we are in our interest is to do the object. So this is the object, so that's how to pass the object. So this is we put include is equals to quote object. By default is numeric. So you have to supply this explicitly that you want the object column brief description. Okay, that is that. Okay, now let's look at that. Let me create another shelf here before we go further. All right, now you can see we have how many columns that are object? 5. Is that correct? Yes, as we have it in the info method. Don't forget, the info method gives us that, so we are already knowledgeable about what that entails. Okay, so name is an object, set is an object, ticket is an object, cabin is an object, and embarked is an object. So we have the count, it returns the count, the unique. So the unique value, it return the unique count of unique value, and of course all of the passenger names are unique. Actually, that's why it returned 891. So it counts 891 unique objects. So instead there are two unique, which is male and female, so no any other one. So so we have ticket 891. So counting the ticket, we have 681, meaning that there are ticket ID that are of the same. So we in cabin we have 200, and this one is having missing value. Okay, we've seen that already from the info, this brief information we have here. The cabin, can you see? So it's missing a lot of value there, but however within that missing value we can still count the unique value in there. We have embark has 8 distinct value 3. Okay, and the top is what the most frequent value is 8. The most frequent value, the top is equal to, both of them has the similar return similar result. However, this one will return the count, while this one will return the actual value that is frequently recurring. Okay, may, then this one will return the count in that column, this one and all. So we can combine the two together, the numeric and the numeric, let me say this one object for object data. So we can combine for both numeric and object together. How do we achieve that? We've seen it initially while I was looking through that. So we have include is equals to all. So my assignment is that, how can we, so you've seen it already, but let me still give you the assignment. Okay, make sure you do it, and having done, when you are done with it, please drop your comment at the comment section. Drop your what your experience is like in doing that assignment. Okay, assignment number 2: how can will get the description of all the column of all the column irrespective of their data type, that is D type. So do that. How? We have seen that, and I want you to implement it. So when you know how, then implement it. Okay, best of luck. So let's continue. Aggregation function. Before we proceed, I want you to do the assignment. Let's take a break. Aggregation function, we're going to be looking at mean, median, sum, unit, and value counts. Okay, to see all the unique value and their frequencies in the data set, you use the value count method. Okay, and STD, like the standard deviation, it tells us about the variation in the data set we are working on. Okay, and of course if you look at this mean, median, and sum, they work on the numerical data type. Okay, we can categorize our column, the data set column, of the any data set, into two data type. We have the numeric and object. Okay, object type. Okay, object data. Okay, so based on the information we got by using the info method, we could see that we have for the what, the integer, 5 integer, 2 float and object. However, the float and integer are under numeric data, okay, and the objects, they are not numbers, they are objects such like string and whole. Okay, now let's see how we can actually apply this. And if you look at the summary, this is also a summary method. If you look at the scribe that gives us the brief information about the data set, it equally gives us the some of the things that we are to look for under the aggregation function. We have the count, we have the mean, we have the standard deviation, the minimum value, we have the 25, 50 and 75 percentile, we have the maximum value of each column, like 7 columns that are numerical. Okay, now so so let's now use me. Let's use me on the data set. We have the media, and of course we have it here already. But however, you might want to just carry out the mean computation on a particular column, not the 7 column we have here. Probably you want to do it on the passenger class. You want to know the mean, you want to do that on a particular column. So let's look at that, how we can achieve that. Okay, the Titanic underscore df, then the let's look the mean of the survive column, survive dot me. So as you can see, what we have here is what this brings to us. So you might want to do a specific column. You want to get the mean of a specific column. You don't need to and you don't want to use the description. You just want to use it as, probably you see the use case of all of as we progress. So let's look for the sibling as well. If you look for let's say Titanic df dot h, okay, sibling spouse dot me. Okay, you can see that now. That's 0.52. That's the mean, that 52% there around that. So that's how to apply that. You're going to see the use case of uh, this as we progress. Okay, let's look at the media. Okay, let's say the median is let's check for the Titanic df dot fair dot media meta. So as you can see, that's 14. So it's equivalent to 50%. That's the mean. What is median? Median is the value that fall in between the data sets. If you have an odd data point, the middle value is the median. But if you have even data points, like let's say 10 instances, that one does not have a unique middle point. It's going to have 2 data points at the middle. So you get the average of that, and the average is you had the 2 data points together divided by 2. That's 50%. So that's how the median is computed or calculated. Okay, now going forward, we have the sum helps add all the value in a particular column together. So okay, let's look at how that works. Titanic. Okay, you asking me if you can just apply sum like this, right? Oh no, you can't, because that gives error. You have to specify the column you want to sum. Can you see unexpected opera hand type? So we have int and this string. Okay, so you have to, I told you this function only work on numerical value. So and we have in our data frame we have both object and numerical value, so that does not work. So we can say dot um let's say survive, right? Survive, let's see how many people survive. So can you see out of the count we have 891 passengers, okay, but out of them 342 passengers survived, meaning the other passenger died. So how many of them died? Let's look at it. 891. Though we have not started the EDA, that is when we are going to be seeing the meaning of all of this we are doing. So we are only going through the two so as to get familiar with it. Okay, after this video, the next video you should be expecting is the video on EDA, where we're going to be looking okay, EDA, the meaning and all. We're going to be visualizing all of this value and talk, looking at what is the implication of this, what does this mean, and how does, how does this and that, happen. So that is what we're going to be looking at, but we are going through the two. Okay, however, I think we are still learning something actually, so that when that video is being released, you are going to get it once and for all. Okay, so let's look at that. How many people died? 9. Okay, let's label it so that we can see it. The number of the people that survived, let's say print. If this is string format method in Python, the total number of the survived passenger is so we're going to put that Titanic df dot sum survived dot sum. So we have 342. So the number of the victim, those that died. So let's look at that. How we can get that is to subtract those people who survived from the total number. Okay, so how can we get the total number? We can say length, or we can use count. Length Titanic dot Titanic length. Okay, I think this will give us total number of the passengers who died is this. So can you see it now? Good. So that's that's how to go about that. Okay, the next method we're going to look at here is the unique. What does the unique do? Unique helps us know, like in the area of survive now, in the particular column there might be unique value, like in under the survived, there are only two value there. The two values are the 0 and 1. 0 and 1. 0 represent the those who are died, and 1 represent the survived. Okay, those that did not die in the event. Okay, let's look at that. Let's say Titanic df dot survive. So it gives us the unique count in that column. Let's look at that. Can you see? So we have 0 and 1. So this unique count work for both numeric and work for all data from it. Work for both numeric. It works for both numeric and object uh, data. Okay, now let's look at that. Let's look at the objects. For the objects, let's look at the, we have other, what other column do we have? Let's go up and see. Okay, we have, for the numeric, let's check it out first. Let's check that out. Dot info. So we have, okay, we can check for the sex. Okay, let's look for that. Count, let's count that. Titanic df dot count, oh sorry, cells. So that's number 4, index number 4 dot count. Oh, not count, what are we looking? The unique, rather, unique, yeah, unique, unique. So you can see now we have two distinct value in that column, at male and female. So in case you want to know the composition of a column in your data set, you can just use that. And of course, for this class too, you can use for this passenger class, you can do that as well to know. Let's look at that also. Let's do that before we proceed. Let's say Titanic. You can work with this, play with it and see what works. Okay, so dot unique. So here we have three distinct values that make up this passenger class. So there are three distinct passenger classes. We have 1, 2, 3. Is either you are in first class, second class, or third class in the plane. Okay, and we have that, so we can uh, go further and play with it, check all the column. Okay, now the next thing we have on the list is this, the value count. The value count returned the unique, as you know, this one we use only returns the distinct value in a column, right? This return distinct value, this return distinct value, this return distinct value, but value count help return the distinct value and the number it comprises of. Now look at this, you don't actually know the number of May in this in that column of cells, right? And neither the number of female in that same, and also you don't know the number of how many passengers are in class 3 or 1 and wherever. So that unit count help us out to get that. Okay, let's look at that unit count. Titanic df dot let's say p class dot value count per. Good. Can you see now? This gives us the 3 unique count as this gave us, but this only gave us the distinct class. Okay, but however, this one return alongside with the distinct classes, it returns the number of passenger we have, meaning that in class 3 we have more passenger there, and in class 1 we have lesser value to that of 3, and 2 has the least. Okay, so that is how it works, and we can do that for the cells as well. Let's say it only equally work on the objects also, not only numeric. Let's say cells. Can you see it now? So it shows that the male are more than the female, right? We have 572 and 314. So we are looking into the data set already, and I know you are getting used to this. Okay, so I want you to play with other column and see what works. Okay, now I commented this out, so in case you want to, let's say I want to show the column which are not objects. I want to find their sum, like instead of me doing it one by one like what we did here. I got this, I retyped it, so you don't need to be retyping it. You can just write a Python syntax to check that out for you. Can you see? You can say loop through. This one say loop. we are looping through this one, loop through the data set column. So column, then here, so we are compare the data type of each column with the literal uh, object type. Okay, so compare. So we first of all convert this. So we get the data type of that one column that we get from the list of column. Then we convert it to string. Here we with this. So you might want to, if you want to know that, you can go study this. Then we say print the column and it's me. Okay, so we print and column and it's me. So let's run that. So it's filter out any object data type. So there are 7 column which are numeric in nature, right? So we have passenger ID, this and this and this, and this is their me. So if you compare their me, let's say the passenger me is this. If you look at the passenger me here, where do we have it? The passenger me is 446. You can see that gives to us. So instead of us repeating ourselves, we can just write a reiterative code to get that done for us. Okay, and we can see survive. We have this, we have seen the fare, we have 32.2 cents. Let's go and see that fare, the me of that. Can you see it now? So instead of we doing it one by one by one, we can actually write a short code to do that for us. Okay, that is that for the aggregation function. So you can still read more on that. Really go to data, cargo, go to W3 schools, and Hall to still get more information, and use online resources. There are a lot of online resources that you can use to help support this on the knowledge that you just got now. Okay, now going forward, we have conditional selection. So you will see the usefulness of what we just did up there now. Conditional selection, what does that mean? In a scenario where you need to filter entries based on a particular condition or a given constraint, this is handy actually. In a condition, you don't probably you want to get the passenger who survived you read all the list of the passenger. By the time you say, let's say, Titanic underscore df dot ed, you will see that this gives us whether survive or not survive. They are all together. What of if our intention is to get the only survived? Okay, we only want to get the survived, not this. We don't want to get all of the passenger, whether they survive or not survive. We want to get only the survived. How can we do that? So that is the constraint. The constraint is only survived, or passenger who are in passenger class 3 only. How can we get that done? How can we select that? We want to say a query, adding a query clause to fetch out data, to filter out the data. So this is most important in the lifestyle of data analyst or data scientist. So this is what you see every day. So now let's look at that. The syntax is, you get the data the data frame name, then the conditions. It could be one condition or conditions. Okay, note, clause might be more than one. That's how I put one that, okay, conditions. Okay, if more than one and those must be true, use and. So if it is more than one and the two condition must be true, must return true, okay, the first condition must be true and the second condition must be true and the third condition must be true, you have to use and. E.g., let's say for a student to get into university, he or she must pass English and mathematics. He or she must pass English and mathematics. So if a student pass English and does not pass mathematics, automatically the student will not be admitted into the school. So the condition is and, not or. If they say the student must pass math or English, so meaning that if the student passes math and fails English, he or she can still get admission into the school. Okay, so the clause, the logical operator used there is and or. And so and means the two condition must be true, or two or more condition must be true. But if you use or means one or those condition might be true. So you get one. Can you say if more than one and either might be true or false, use or. So we're going to see that now. Let's see first and foremost, we want to select the passenger who survived, the event, the passenger who survived the event. How can we get that done? Let's say Titanic df dot df, then the condition comes in. How do we supply that condition? Say Titanic underscore df dot survive equals to 1. Survive mean that's one, those people that survived. Okay, let's run that. Can you see it now? It gives us how many row? It gives us 342 people who survived. And if you go up here now, if you go up what we did here, the total number of the survived passenger is 342. Can you see it now? So you can see now from the conditional statement, now we are able to fetch out that. So now this table, now we have, you know, explicitly all the survived passengers. So in this table now, we don't have the people who died there. Okay, so we can do analysis on this table alone to see what is the age group, the I age, the age group, the age of the survived individual and all. We can save it in a we can save it in the variable to see that. So let's say survived passenger, survived passengers is equals to this. So good. So we can print the variable. So might want to use it later, so that's why I'm saving it inside that. Okay, the spelling is not divine. Okay, let's see the survive pass. Okay, double S, triple S. Okay, good. So we have that, right? So we have the length. Let's see those who do not survive as well. Let me copy and paste. So how do we get that done? How do we get this unsurvived, not survived, unsurvived? Okay, let's use unsurvived passenger. How do we get that? How do we filter that? You know, this one will still give us what? Let's see, unsurvived. I know you've gotten it already, right? So well done. So you can see it still gives us what? Those that survive, but our intention is to get unsurvived. What do we do? So we having note that we have how many classes? How many classes do we have for the survived? For the survived column, we have two classes, 0 and 1. So the first one is survived and 0 means died. Okay, so now unsurvived. So now in this condition we are going to change the value to what? 0. So that gives us the number of, can you see, we have 549 instances of passenger who did not survive the event. Can you see? So sad. All right, let's equally see, let's select other let's use it to select the classes too. The classes, let's see the classes of the let's say class underscore 3 is equals to the passenger in, okay, passenger in class 3, passenger, okay, let's write it in full just so we wanted to do the passenger in class 3 equals to Titanic underscore df dot passenger, that's p. So condition, I told you the syntax, follow the syntax. Let's see the syntax again. So this is the syntax followed with the condition. Okay, let's go down. Where is it? Where is it? Good. So we say Titanic underscore df dot the passenger class, that's where we want to get the value from, class equals to 3. Good, we've run that. Let's create a new shell so that's to print it out. Passenger in class 3. Can you see that now? We have 491 passenger in class 3. Now from here we can see how many of them survived. How many of them survived? So if we want to do that, okay, before then let's look at this. Is this correct? 491. Let's see, 491 passengers. Can you see it now? Okay, class 2, 491. So how many of them survived this event? How many of them in this class survived the event? You can still do that. You can say, okay, passenger in class 1 who survived. We are going in depth already. Okay, that's good, that's fine. Okay, so meanwhile the next video is going to be on EDA, exploration data analysis. Okay, EDA. So we are going to be visualizing and also talking in the meaning, how we can infer meaning from what we are doing, the calculation we are doing. How can we explain this to the non-technical individual? So now this is equals to dash. So how do we get that? We say, okay, passenger in the class 3. So the condition who survived. So passenger, we've already filtered this passenger from passenger class 1 and class 2. So we are considering passenger in class 3. Okay, so genders dot in class 3 dot survived equals to 1. Good, we've gotten that. Let's print it out. How many of them? Let's see how many survive. So you will see that we have 119 who survive. How many are they? They are this. So let's see that. Let's see the number of minus. So this helps us to minus this. So you see now, no, the number who survived. Okay, it's supposed to be the number of passenger. Okay, yeah, passenger in class 3 minus passenger who survived. Okay, so let's run that. Good, you will see the difference between them is 372, meaning these are the passenger who did not survive. We can equally compute the percentage of the survived passenger. Let's see it. You can say divided by the total survived, divided by the total, multiplied by 100. But because of the precedence precedence, the operator precedent, we need to put it in brackets. So this one divide first, then multiply. So multiply by this. So let's see that. Can you see that's 24.2%? Let me just put it in a percent. So this one should be in curly bracket. So let's run that. So we have, and of course I can equally make it to be, I mean, let's say 0.2f. Good. So this is to just format it into two decimal places. Okay, so we have 24.24% that survive. Okay, the percentage of the the passenger passenger passengers who were in class 3 and survived the event is, so you can see now this is more elaborated. So I want you to work with that. Just your assignment, you can pick, I can say a specific, you can use age to do that, or sibling size and all, to just walk around it, and whatsoever thing you do, please come back to this video and drop your comment in the comment section. Engage with the video, let other people learn, and share with your friend. Okay, let's look at sorting. We have 3 topics left. Okay, so sorting, what does that mean? You can sort, that is very, very essential. It's also, it's in most of the time you might want to sort ascending order or descending order. This is the syntax. Okay, we have data frame underscore the name dot sort values. I hope I'm not too fast. Please let me know, and I believe you're getting it. So sorting syntax for that is that the name of the data frame dot the method, then you pass in the column you want to sort by. Okay, note, by default the above command would produce an ascending ordered result. Okay, by default ascending order, but for if you are interested in the descending order, you have to pass another argument. This is the argument. Ascending is equals to what? False. If it is by default is ascending order, it means the ascending order is set to true. So you have to do that. How do I know? Okay, let me show you that. Help. We have been using this since now. Titanic underscore df dot sort underscore values. Let's close the, okay, I think there's a, yeah, can you see it? This is it. So if you look at ascending order, is a boolean value, which is set to true. Can you see? I told you it's set to true. Can you see? So for you to get the other side, or descending order, you have to set it to false. Okay, now let's look at how that works. I'm going to be doing the descending order. I'm going to give you assignment. You try the other one yourself. Okay, the descending order yourself. So the syntax say the name of the data type, the data set dot sort values. So we want to sort on based on the column we want to sort with. Okay, by column name, let's use class. Yes, let's use passenger class. So I'm saying by is equals to, in quote, passenger class. So can you see it now? If you go The ascending order, it starts from 1 2 3, you extend 1 2 3, then 1 2 3. So 1 2 and 3. Okay, unlike if you look at it, pay attention to this result we have and the previous results we used. We can you see the printout we have here, it shows 3. Okay, let's go up and see where we have it printed. Okay, this is the first head. Can you see? This is not even arranged whether descending or ascending order, is mixed. But here now we have it arranged orderly in ascending order and descending order. So I want you to check it out. Also try other way of arranging, this. Okay, okay, that's the descending. We've done that already, so just try it out, read about it and all. Now rename it. I want to make this video more explicit. Me also, while making it explicit, also checking out the time. Okay, also checking out the time. So rename, so we have to lecture left. Okay, so all right, now renaming. So let me give you this as assignment. Okay, let me give you renaming as assignment. Why I do the missing value renaming. Okay, okay. So I have the syntax there is there already. So that's your assignment. Let me change it. Assignment. Assignment. Okay, that's your assignment. Best of luck. So now handling missing data. This is very, very crucial. It's very important because at any point in time that you have data set to work on as a data scientist, you might face with this situation where the value are not complete. So since you'll be working with the real world data, real data, not synthetic one, of course you will be having some missing data. And how do we handle that missing data? That's what we want to talk about. There are two ways of handling it. Is either you drop it or you fill it, not on a random suggestion. You have we have method by which we can use to do that. I suggest that in my own opinion, can you see it here? Though based on the volume of data we are working on, if the missing data takes, let's say, 10 to 25%, 10 to 20% rather, of the data points, we can fill those. However, if the missing data point takes 40 and above, I advise we drop those missing data points so as not to get biased or ungeneralized results. Okay, so it's better we dropped it if it is 40 and above. Okay, so let's look at that. The three scenarios that can happen is what? The two scenario is either drop or fill. But however, how do we know that we need to fill and drop? We need to know if our data set comprises of what? Missing data. And of course we have missing data here because from the info we have here, it shows that the age, we have some value missing here, we have some value missing here and also here. So we have 3 column missing value. So we know already, but sometimes it might not be obvious to us to see all of those. So you can equally check it out by using this. So that's the checking if there is a such situation. So we can use this method or this method. Both are the same. So to do that, let's say Titanic. The syntax say the name of the data frame. Titanic df dot is now. Let me use the first method. Can you see? So it's this one gives true, false, true, false, true, but you can see we have true here, we have true, we have true here, then we have, so we have it here also. But all of those, now that we see that we have missing value, in some cases we might not see it obvious like this, we might not see it in such a way that we have it here. Okay, so but however, it is important. Let me do it this way. That's sort. Let's use sort values, sort value, but not all the time you'll be using this. Okay, let's say sort cabin. Let me see if that will give. Okay, should be string value rather. Can you see? So with this one now, we were able to see. With this, we were able to see that this is, we have false value. However, this is still not, make obvious that we have missing value. So what do we do? What do we do? So in my opinion, if I will, I will advise, but in some cases it's not like that. Let's say it's not. Okay, let me copy the code I have here. Okay, this same code, let me copy it. I will just modify it. So it's not going to, I'm not going to be asking for any condition here, because this is both numerical. So it's not. Okay, so what I want to do, I will keep track of the value, the missing value. Let's see. So I will say, let me declare a dictionary missing values, value is equals to dictionary. It's going to be a dictionary. Yeah, let's say dictionary. Then it's going to be the value is going to be missing underscore value is equals to dot, or we put f, then equals to, is going to be least value, missing value. I'm trying to see, is equals to, so we want to count the missing value. Okay, count. Let's say length. Is it length or sum? We can use length, or let's say sum. So let's see if that works out. Missing value. Good. Yeah, it works. So you can see now that we have age, we have these three column, they have missing value, and you can see three of them. So this, you can just look through this. It's very simple. This is just Python. If you would like me to produce video on Python tutorial, please drop your comments in the comment section. Okay, if you want that. All right, now going forward, now we have seen that we have missing value, which are here, this, and this. So let's look at how to fill it. But however, let's see the percentage first and justify our if we are going to do that or not. Since we have this and this and this alone, I think we can go further and bring something. Okay, so let's look at that. Yeah. So let's look at that. I think Titanic to okay, now let's look at the percentage of the age. The percentage of the age. How do we get that? P F. I want to divide sum the age dot age dot age divided by the length of Titanic age df dot age. So to get the percentage, the number of true divided by the total number of the age multiplied by 100. Multiply by 100, but before then let me wrap this in bracket, then multiply by 100, then put percentage at the back. So we have the missing value, age missing value percentage is this. So let me limit it to 2 decimal point, 0.2f. So that's that. So let's check for the other one too. You know what to do. For the cabin. Yeah, cabin, missing cabin. Then here we are going to change this to cabin and this to cabin. So 77.10%. Wow, it's too much. Can you see? So let's check for this as well. I think this one is very, very minute. However, we can't say because of the embarked. So another thing that can influence our decision from dropping them any column is, should I say, it's not that important in predicting the outcome of an event. We can drop it as well, but if it is very important, we need to find our way around it, whether to fill it or we're going to get that as time progresses, as we produce video on that as well. So let's run this. So this is 0.4%. So because of this, we will not be dropping we will not drop it. Rather, we can drop this column itself. Because if you drop this instance now, it's going to affect other the entries. Okay, but we can drop the column. The aim of this video is to show you that there is missing value, how to fill and how to drop. So we're going to drop the column. So how do we drop the column? It's very easy. So we can just say let's see, how many columns do we have? So these are the columns. Okay, these are the columns. We can just say embarked. So we can list everything out. Let's say features, or let me say column is equals to list. Let me list everything. Let me just type it. Survived passenger class name, sex, age and sibling, spouse, parent, children, ticket, fare, embarked. We are dropping that. So good. Now, Titanic, the data frame is equals to Titanic underscore df columns. Now, Titanic df. So as you can see, we have 11 column now. So we've removed this so that it won't affect other column. You know, it's supposed to be 12. So we've removed it now. Can you see it now? Very simple. So this is slicing. Okay, we've already removed that. So now let's see how we can fill. Having removed that, now let's see. Let's run this again. Let's run this code on this particular one to see. So missing value. So you can see now we only have age and this. So now let's fill this one. Let's fill this one. Okay, let's fill that. So it's considerable. All right. Now, how do we fill? If you look at that, we have this and we have this. Okay. Now let's take the syntax to fill. So we have the data frame name is Titanic df dot free nan, that is free non-value. Then the new value, what are we using? We can use the mean of that column, or we use the median of that column. Now for the age, we can use the mean of the age. So how do we get that? We can put it here. Can say Titanic underscore df dot age dot mean. So we have to add the column that we are working on as well. So it's the age you want to fill with this. So let's run that. Good. So what is it saying? A value is trying to be set on a copy of a slice from a data frame. So okay, now let's run the data again. Let's run it again. Let's run this again. Let's run this again and see if we have, if that has been worked on. So you can see now that age has been handled. So let's look for this as well. Let's look for that. Okay, to resolve that, let's see the unique value we have in the embarked dot count value counts. You can see we have this. Okay, and we can use the most occurrent value to fill the missing ones. Okay, the missing one is just only two entries that do not have the value at that embark column. Okay, so we can fill it. Very simple. Titanic underscore df dot embarked dot fill now. What are we filling? They supply the new value, new value, and in place is equals to always true. You have to put that, if not it might not changed. All right, now the new value is going to be the most occurrent one, which is the s. We have seen it already here, so we can just put dot x, capital letter X. So let's run that. Good, we have changed that. So if you run this code again, you see it has been resolved. Run that code. Let's missing value. Now you see that is no more. Everything has been solved. So congratulations on the lecture 2 data frame tutorial. So the next is going to be on the
EDA tutorial. And don't forget to subscribe to my YouTube channel for more tutorials. Okay, thank you very much. See you in the next lecture.